Welcome to the lecture series on object oriented analysis and design. As seen in the last lecture, rational rows remains one of the most popular, widely used tool to a point where, as we have been saying, that OOAD is synonymous with UML today, rational rows is also synonymous with UML. What is the reason why we took to case tools? Whatever we do, we are hovering around 30 to 36% success rate. We acknowledge that requirements are very difficult to stabilize. 70%, nearly 70% of requirements can vary as we begin and try to come to a close to a project. Amidst all these well known traits of software engineering and development, we have taken up the challenge of trying to understand what to do with this kind of a volatility in requirements, the kind of a change we have been promising. Nothing is cast in stone, anytime we can change, because we do strongly believe that none of the stakeholders are so crystal clear as what is happening, they can't describe. Riding a bicycle is lot more easier than writing 40 pages or explaining to somebody that this is how you ride a bicycle. So, there are so many things which we do, and therefore, what we have been telling is the very nature of software engineering is such that whatever you want to automate, whatever you want to computerize, you should think very clearly about what you are doing. Towards attaining that clarity, we have been talking about a requirements phase, a specification phase. By design phase, hopefully all the people will come on to some same page, the developer, the stakeholders, the customers, they think that roughly this is what should be done. So, having said this, takes time, documentation is not so strong, phases are different, all the things that we have been talking about, and after all technology solutions have happened, today, that is nearly 50 years after software engineering has been developed, we are telling that about 30 to 36% of the projects succeed. Now, the traditional or ad hoc methods still dominate because we have a cushion here saying that not many projects fail. The iterative way of doing things, that is, in this iteration we do this much, next iteration we do this much, it has been very good. The iterative development has been exceedingly good for the web development platform, internet programming, because we cannot wait for a full maturity of whatever we want to do to happen. The web world is so fast that whoever gets first to the web is likely to succeed commercially. The idea is good, it can get into that internet world wide web, but then whoever gets to the web has a very bright chance of succeeding with that idea than people who may do better in theory, but then they are second or third, the first to hit the web. So, what has happened in the world of internet related work, internet related products is, let us get on to the exercise first and then build further, next iteration will be better, next iteration will be better. Now, please understand that it is not the same as versioning that we used to call traditionally. Traditionally, only version 2 of your software works, all others are just trial versions. Iteration is not the same. We need to show some good progress, we need to make sure that we are factoring the feedback well. So, it is a specific process, but then we are running a huge risk here. 20% of the projects fail, and most of the times we are getting challenged. So, what we have been telling all along is that the traditional has given the best margins, 30%, modest 30% required success rate, where we said that 30% requirements are stable at the beginning, 30% we succeed, and failure rate is not so predominant, 67% challenged. So, at a pinch, that is, we accept that more money has been spent, more time has been spent, we are likely to come to this 36. This is what is our hope, we do not have to change the process. Agile is separate, it is just 8-hour working day, tomorrow is different, next day is different. Continuous delivery and lean, hardly 5 to 6 members in a team, we know the limited exercise. So, the concern here is that if you really want to address the complexity that we are talking about, using these solutions, object oriented and other things, get back to the traditional methods at the earliest. There are ad hoc ways of doing things, but then as I discussed in the earlier lectures, OOAD is spanning across a very good software development lifecycle process, a nice blending with organizational and support services defined as processes. Anything that is defined as a process is fitting well into a chosen quality framework. We have a set of metrics, the metrics will tell where it is, we can make it systemic, because we are very good as sequential thinkers, but then we are not so good on systemic thinking. Now that we have brought in the systems very high up in the phase, soon after requirements we want to do one systems check. So, since we are doing a very good systems check ourselves very early in the way we are progressing, we strongly think that if we get back to the traditional ways of doing, adhere to the ways in which software engineering principles were happening, the practitioners were doing, then we are likely to show something like 36 to 40% of projects getting succeeded, or what we are calling as challenged are not really leading us to failures very soon. This huge failure is not likely to happen, but then this area is something which is still manageable, and who knows, we may say that very good methods have happened, good teams have formed, we can easily get to 30%. The trend is like that. Once again we said that modeling, object identification and modeling, this is very good in the way in which we have been doing as ad hocism and agile. Traditional methods are good, they are sort of 67% of what agile and ad hoc methods are doing. Even in this case, sketch to think and communicate, it is absolutely essential. On a longer life cycle, we should have some way of getting it back, otherwise what we are doing is the terminology of project is gradually being replaced by product. We have done this, if the product is good, please use it, otherwise keep it aside. The product world works like that, there is nothing wrong about it, there is nothing wrong about making things commercial, and we have seen this exercise earlier on. So, most of the times we like to do some whiteboard sketching. There was a nice tool called storyboarding very early in my career. We were talking about storyboarding. You talk about whatever you want to tell as a possible idea using a storyboard. IBM was having this package called storyboard. You can exchange some simple graphics, you can exchange some simple dynamics. If nothing else, we will simply say that all right, these have been simply exchanged. Now, what we have done is we take a whiteboard and then start doing some sketching on that. Your sketch becomes very obvious. Initial agile requirements modeling, all this is fine, but what is giving us stability? What is giving us very stable way of doing things is case tool modeling. These are all very rudimentary. Paper modeling vanished, it was useful, but it vanished. Agile, we know the limitations. Whiteboard, we know the limitations, we cannot be distributed, we simply cannot find a way of talking about it. In some sense, we keep saying that the teams are likely to be global, even if it is lean, half a dozen people are elsewhere, they are talking in different language, different time zones, that is how it is. So, what we have done as UML is take into account that the fact remains that there are multiple stakeholders. People are not likely to talk about every model in all its detail. Adequate transparency, adequate interfacing, adequate interoperability across business models, requirements model, analysis model, design model, implementation model, testing model, based on multiple domains of expertise. We are not talking about single discipline anymore, multiple domain specialities, domain experts, only then we talk about object identification and modeling. We have thus arrived at a process. Why is process making us feel comfortable? It fits very well with the chosen quality metrics, a set of quality frameworks, whichever you want to use, it blends very well. So, Rational has given us a tool, Rational Rose, which is like this, and what we have done is we said that this is how it is working. Rational Rose is a set of visual modeling tools, and when did this happen? Roughly UML got stabilized somewhere in 2001, 2002, and we said that that is how we built a tool. I must make a simple recourse saying that when it began, when all this exercise began, we started talking about using the tool only with the formal certification. I must thank my university and my department for sparing me for so many days, 12th to 16th May, that is a good number of 5 working days, and it was done here in Chennai. And I was also in a team that was coordinating the procurement of Rational Rose. 2002 it was released, very early May, one of the early institutions to procure Rational Rose, and I was working with that team which procured Rational Rose. It is quite costly also, but then nobody thought that it will be such a runaway success that till today we use our laboratory courses based on Rational Rose. So, it was a very good exercise. They had all these ideas, but then the concern in products is that the sales of the products will determine how much efficient this method is going to be, how many people can be certified. It got into limelight very soon. 2004 it was practically swamping academics, industry, people simply wanted to get Rational Rose. All laboratories were supposed to be on Rational Rose. We may not be mentioning it explicitly, but it is like that. Is it possible to have, let us say, so many people who are certified? The certificate of completion was later, the contact was 12 to 16, 5 days. After that we have to solve some problems, do some exercises. The methodology was also very interesting and very nice. So, what we have done is, if it is completely product based, the sale of the product will determine how efficient this method is going to be. Gradually it has become a case where we may find it very difficult to train so many people. So, the typical training methodology is changed. We have to get on with the tool usage, everything has gone back to the idea that depending on the organization, they will keep using the tool and learn how to use it. That is how it has happened. It becomes very difficult, it becomes a humongous task. So, what we have done therefore is that where it is so specific, and we do have a methodology, the idea is not new, it is a methodology that we have been following, but then please understand that it is better to have training, even though it is a very simple tool, and I am oversimplifying on what it has been doing also. It is rational object oriented software engineering. Rational Rose is a set of visual modeling tools. What we have done is, it shows so much richness in the diagrams, 9 diagrams and 11 things and 4 views. Each time when we revisit the exercise, we may get a different view, but with practice, with experience, we can be conclusive that 4 different views are enough to tell that this is exactly what is feasible as analysis and design. After that, we can integrate it with automatic code generators, and what we need is very simple idea. So, please note that it facilitates the use of unified modeling language, component object modeling. DCOM was also included later, OMT and Booch 93. So, when I did this course, it was fresh, May 93, it is almost the first cut, Rational Rose. Very exciting course, hardly 20 people were there, if I remember right, 20 plus people were there. And when I really wanted to do this course, it was done. Anna University has been one of those early clients. So, we got a free seat and it was nicely facilitated, and what we did was nice, 5 days intensive contact program and then problem solving exercises. Finally, the certificates arrive. It is a good idea, it needs that much of focus. The point I wish to make is, even though a few screenshots are there in this lecture, it is so much of a tool. It handles great complexity. None of us is really anticipating the potential of this tool correctly, even the very first tool, and it helps. The certificate was very valid. It took me nicely into many more things in the object oriented analysis and design area. Rose uses the UML to provide graphical methods for non-programmers wanting to model business process. You can do programmer, you can do with programmers, you can do with non-programmers. It is a case of trying to understand that richness of a visual medium which Rational Rose is supporting, 9 diagrams, 11 things and 4 views. That is how it is described most of the times. You can take it middle of the project, early project, things may not be so crystal clear, but then middle of the project it helps you re-engineer, reverse engineer. You already have a tool, you try to understand, you give me a tool, any tool, work for some time, you will have your own ideas about how the tool might have been functioning. Pinpoints deviations in the original design. ROSE offers a fast way for clients and new employees to become familiar with system internals. It is much more faster. By saying so, I am not trying to aggressively market Rational ROSE. As I said, being from an academic institution, it is good to take stock of a dozen tools. A dozen tools are listed here from 1996 to 2015. The tool which I am talking about is 2003, that is Rational ROSE. Very first, very fresh exercise it was. There are so many other case tools with comparable features, with the limitations on analysis and design. By far, this is the simplicity with which we work on Rational ROSE. This is all you need to know. UML is trained elsewhere. UML has been defined not by Rational Corporation, but by Object Management Group. They said this many diagrams will be there, this many things will be there. The Rational people got together and then made it happen. Like everything is tailor made for you to get hands on with UML and address a complexity which is very huge. It is not simply a toy program, but it is a very good complexity which you can address. I have been talking about a host of applications. There are other paradigms. Say for example, with the artificial intelligence coming back for a third wave, or maybe some people say it is a fourth wave. So, when AI is coming back, we are once again going back to functional programming, logic programming, at least as academic and research exercises. We are still talking about Prolog days, we are talking about Lisp days, the way we have been doing. There are different paradigms. Once again we say the same thing, we have had the same debates. In the earlier lecture also I was mentioning that there are, let us say, tangible objects available. In addition to object oriented, we need object request broker architectures, where a request is made on the network and then it has to locate where is the matching service for that request. I want to do this, who can provide me this service? This is what was the essence of component object modeling or object modeling technique. However, we do not know, a request goes on the net, a service should come. There are two dominant technologies in this area of service oriented architectures, web services and cloud and related cousins of cloud, grid computing, edge computing, lot of things. There are so many other related areas technically related to cloud. So, what we have been talking about is this was good, but ORB was not giving us a scalability of services which cloud was promising, and web services another promising technology, but it did not scale that much as cloud or grid or whatever it is. So, unified modeling language is good. Now, once again we are talking about the same, saying that Internet of Things is likely to bring back object oriented in a strong way, because we keep saying the same thing, whether it is AI or machine learning or whatever it is. Internet computing has some very strong linkage to the idea called thing. What we are representing is that thing, and we work with the things, it is not with it. So, that is how we have been talking about most of the times, but however, we need to understand that things have become more interdisciplinary. In the beginning, when we said that we are talking about a vending machine, snack vending machine, we are dealing with a thing first in our minds, then we deal with the machine which is vending snacks. We had a simple example, there is a price, there is a calorie value. Every customer is calculating on the price and the calorie value. There is an interface for that. Initially, all this is done in this model in an abstract manner. When the customer actually works with the machine, it behaves the same way. This is acceptable behavior of the machine, it works like this. So, what we have done is use this simple tool, simple pane, it is tailor made for UML, absolutely tailor made, and most of the times it is in conformance with the UML standard. Now, mostly it is in conformance. The early versions of ROSE wanted to establish something new, but now it is mostly in conformance with the UML. UML is very popular. All textbooks on OO, object oriented, have gotten on to UML. Last 17 to 18 years, OOAD became synonymous with UML, and UML If you talk about a tool, it is only rational rows. 4 views are enough. We do not have to keep on assimilating views, keep getting on views. It tells nicely, tracks the views. It tells the essence is how to converge. Once you converge, you can simply choose a language, press a button, the code will automatically be generated. So, these things were not so strong in the version of rational rows which involved in procuring and got trained, code generation, automatic code generation, but however, it spans across all the models that we have been talking about. Typical interface, a very simply captured image, it is lot, there are so many options. It is a very rich tool for the object oriented analysis and design. It is very nice, very useful. I am not marketing this tool alone, there are dozen other tools, competing tools, more than dozen now, a score, 20 tools are very easily available. After all that, rational rows remains the market leader over a surprising spell of 18 years. Rational rows diagrams, it tells how to create a diagram, how to link a diagram, how to display a diagram, how to rename a diagram, how to delete a diagram. A shallow delete, that is, it is not so strong, without a name, rational rows will delete the model element completely out of the model, mask it and give. If you want, you will bring it back again. Even today we do the same thing, you delete a file, you can restore from the trash can. Deep delete, right from the shortcut menu you can do that. How to use rational rows, select a diagram, right click a shortcut, adding diagram elements, setting up default, it is just that, think in diagrams. What diagrams? The UML diagrams. What is the model that you are building? Across all the business models you are able to work on. There is a class specification, the cardinality concurrency, this became quite popular in all ways, industry, education, everything lapped it up. It is now no more classified as academic or business. It is a very good tool, very stable tool, worth mentioning time as a case which is there, easy interface, very tailor made. It tells you this is a sequence diagram in relation with the collaboration diagram, an activity diagram, deployment diagram. At the end of the day, all the diagrams are related, otherwise why are we drawing those diagrams? In one view you will get 3 diagrams, another view you will get 4 diagrams. All of them are related. You touch one diagram, it will tell what are the other diagrams that are impacted. It is a nicely designed and well developed tool. The deployment is something which is absolutely essential. In the beginning, we were talking only about what is called installation. That was the goal of all software engineering exercises. Whether you start with the puzzle, whether you convert it into a problem and its solution, whether you want to call it programming as what you really want to do, or whether you want to mature it into software engineering, that means there is an anticipation built, there is a predictability built in the software engineering, unlike in the programming case where when we arrive at a bug we debug. Here we are talking about defect, it is there, we have to live with it. Every 1 out of 10 lines is defective, like I mentioned in the earlier lecture. If you are developing 10 lakh lines of code, however crude a metric it is, whichever language it is, 1 in 10 lines is defective, that means you have already given to the customer 10,000 defects. So, we are always running that risk of saying that maybe we are only building defects and not software, and the customer will have sob stories. Maintenance phase becomes a very prolonged exercise and very important exercise. We tend to do that. How to avoid this was a question. We thought that many things are trickling down to longish maintenance phases because we only modeled what is called installation, that is, you simply load the executable on the machine, just say run, install. Most of the times we are quite happy with that. That idea is something which meets our mind. We do not want to do much. Is there a new software? Yes. Did you download the executable? Yes. After that, what should I do? Double click on exe, automatically one install package will start, it will tell you installing, installation in progress, please wait, 10% installed, 20% installed, 30% installed. So, we are quite accustomed to that. None of us want to really go into the nitty gritty of what was it that the fellow was trying to develop software for. We do not even want to think about the problem with which we started or a solution with which we have to find out. We know that after all the discussions, everything has now gone to the desk of the developer from my table as a client or a stakeholder. It is all with the developer. They have been toying with all these programs, they have been toying with languages, decisions, tools. It is up to them. I am giving them as much time, promising some money on that. They came back saying that this is what we want to do for you. Call it a program, call it a software engineering, and since you did not have this machine, we request you to buy this machine. We are putting everything on that, the exe is there. All that you have to do is locate the installer, installation package. You can do it yourself, just press it, double click on installer, it will start installing. After that it works. That is something which was a very, very catchy idea in the early days of software engineering. That should be the goal. We should not do any more than that. We cannot do anything more than that. After that, we said that it is becoming very difficult. The idea is good. We want to have installers, we want to have only installation phase, but then it is becoming very, very difficult. So, we spent more time. We said that let this phase be called implementation phase, where we do some exercise. We have a machine there, we like to do some more exercise on how to tailor it to the client environment, help them do some hand holding, make one testing called acceptance test happen. Let there be one acceptance test, people, a sample of your stakeholders will come, will work on it and say that yeah, for most of the features which we are expecting, it is doing well. Whether it is a great test or not a great test, that we will talk about later. Most of the times the joke is always alive. Acceptance test is done by people who know nothing about the software, who know nothing about how we started. They only know that they have 5 tasks on hand. Is this piece of program doing it? So, implementation phase started giving us some tests, test cases, something happens, we will have to be there. Then we matured it further, we called it delivery phase. What is the delivery phase going to tell? A part of the development team, a part of the HR team will go to the client side. The delivery phase is a more prolonged implementation phase. We will have more discussions, more deliberation. The cost is becoming prohibitively expensive. That is how the traditional software engineering model has taken us from installation to implementation to delivery phase. Plenty of problems have been arising. Most of the times the HR is on the fire and they tell that no, we have already told you it should have been done like that, it is not done like this. A lot of friction has emerged, and therefore gradually we took recourse to this original idea which UML has given, saying that deployment diagram, before the first diagram is drawn, before anything called next step after OOAD happens, we should be very, very clear about where exactly is the program going to sit, what is the context, where it is working. Deployment is in the context, that is where we try to bring in the context. So, now we know that right at the beginning, right at the time when we have said that we have done good OOAD, we know where it is going to work, precisely where it is going to work. So, this is what we have been talking about. Take the example of your space research. The camera was made here, the camera was not done in the moon, but then they have anticipated brilliantly that this is how it should work. In a particular orbit at a particular place, this is how the systems work. That is the idea of deployment. That is when we are talking about what we want to do at a place where the actual piece of software which is engineered like this should work. Thank you very much. So, in summary, we close all discussions on case tools. A dozen case tools were mentioned, plus another 7 or 8 which are close competitors in various ways. In a particular department they score over rational rows, but the focus remained on rational rows, and it takes that much of time, takes that much of commitment. It is a good tool, lot of features are there. I would strongly suggest that people take a formal training and then use this tool, it helps. Most laboratories today are using rational rows. it's good. Those who are familiar with rational rows are always given a priority everywhere. Thank you. We will meet in the next lecture.